Today we are discussing mole mass relationships in chemical reactions. Basically, we are studying stoichiometry for today. So, first concept is the meaning and usefulness of the mole. What is mole? Mole represents a certain number of objects. SI unit definitions: the amount of substance that contains the same number of entities as there are atoms in 12 gram of carbon 12, which is standard for comparing masses. Okay, exactly 12 gram of 12 carbon contains 6.02 multiplied 10 to the power 23 atoms. Okay, 1 mole contains this is Avogadro's number represented by Na. Okay, 1 mole of H2O contains 6.02 10 to the power 23 molecules. This is, you can see, like 6.02 multiplied by 10 raised to power 23. This is okay. 1 mole of NaCl contains 6.02 multiplied by 23 NaCl formula units. How we can know what is formula unit? Basically, almost all the formula units contain one positive ion and one negative ion. But NH4, NO3, like you can say, ammonia compounds, NH4 like contains are formula units, but they don't have one you can say one metal or one non-metal. Here both ions are non-metals. Okay, but in NaCl, Na positive is metal and Cl negative is non-metal. So how to identify formula compounds? Okay, formula units that we can say, like, one is metal and one is non-metal. Okay, use the mole quantity to count formulas by weighing them. Okay, mass of 1 mole of particle is equal to mass of particle into 6.02. This is Avogadro's number. Mass of one atom in AMU, we multiply this by 1.66 multiplied by minus 24, which is equal to 1 AMU. Okay, to get into grams mass of one hydrogen atom. Okay. Okay. The mass of an atom in AMU is numerically the same as the mass of 1 mole of atoms of the elements in gram. Basically, AMU is the, like you can say, smallest unit. We cannot measure this. So in measuring we use grams. Okay, for better you can say, because AMU is not measurable. It is very small quantity. Like you can say 10 raised to power minus 27 kg. That is a small number. Okay, you can say, like, if you have like an apple, you cut it into pieces, you can say 1 billion pieces, 1 billion. Okay, then take one piece out and then cut that piece into 1 billion more, and then take one piece more from the, like, second part and cut that into billion parts. Like, this is for example of how small value this is. Okay, concept: relation between molecular mass and molar mass. Okay, what is relation? For compounds, the molecular mass in AMU is numerically the same as the mass of 1 mole of the compound in grams. Like you can say, molecular formula mass is same, but units are, you can say, because molecular mass we write this in AMU, but molar mass we write in grams. Okay, skill 3: calculate the molecular mass of the compound as the sum of the atomic masses of its elements. This is how you can calculate molecular mass of H2O. 2 into atomic mass of H plus atomic mass of O. Okay, we get 18.02 AMU. So 1 mole of water contains these particles, has mass of 18 grams. Okay, molar mass of NaCl here. Okay, you can calculate this. Yeah, to obtain 1 mole of copper, weight 600. Okay, you have like molar mass. Okay, like the mass is, copper mass is 63.5, molar mass we know 60.5, so 1 mole and 6.02 into 10 raised to power 23 atoms. Concept: relation between among substance, mole, and mass and number of chemical entities. The molar mass of substance is the mass of 1 mole of entity. It is for atom, it is for molecule, it is for molar units, and it is for ions as well. Okay, molar mass has units, grams per mole. You can see definitions here. Isotopic mass. What is isotopic mass? Mass of an isotope of an element. Unit is gram. IMU, atomic mass. Unit in AMU. Molecular mass, sum of the atomic mass of molecules. Every mass of naturally acting isotopes of the variety in their abundance. Okay. Molar mass. What is molar mass of 1 mole of chemical entities? Unit is gram per mole. Okay. Okay. Skill 3 to mass mole conversion. How we can convert mass into moles and moles into mass. Use the molar mass of an element or compound to convert a given number of moles. This is the formula: mass, okay, number of moles multiplied by number of grams divided by 1 mole. Okay, if we are given okay, okay, we can calculate mass by using this formula. we can do the reverse with 1 by m. Okay, you can see one number of moles, mass, moles comes upward and number of grams downward. Okay. Okay. Use Avogadro's numbers to convert moles to substance. Number of entities, you can say number of particles, number of moles into 6.02 multiplied by 23 divided by 1 mole. Okay, number of moles, number of entities, like you can say this is like 1 mole is written, you can neglect this in formula. Okay, write these stuff. Okay, yeah, how we can mass from element to moles and into atoms of elements, we can convert these three into each other. Okay, but we cannot convert, like you can say first mass to moles and then atoms. Okay, by atoms we convert into moles and then into mass. Problem here, how many grams of silver Ag are in 0.0342? Okay, calculate this by yourself. How many atoms of Ag are in 0.0 mole Ag? Okay, calculate these things. Okay, first one, moles, we like have mass. Okay, we know that, like you can say molar mass. Okay, and this is like moles. Okay, this is moles and this is molar mass of Ag. So we get our answer 3.69 gram of silver. Okay, into atoms. Okay, we write moles here, particles here, and convert into number of atoms. We will get 2.6 into 10 to the power 22 atoms of silver. Okay, another problem here, iron is the most important metal in society. How many iron atoms are present in piece of iron ring? You can see calculations here, same formula used here. We find atoms with the same formula. Okay, like we discussed earlier. Concept 4. The information in a chemical formula, the sulfur dioxide SO2 shows its molecules contain 1 sulfur atom and 2 oxygen atoms. Calculate its molar mass. We know sulfur is 32 gram per mole and 1 oxygen atom 32 gram per mole sulfur, and 1 oxygen is 16, so we multiply it by 2, we will get 64 gram per mole. That is molar mass of SO2. Okay. Here, see here, we can, if we have mass, we can find moles of a compound. If we find moles of a compound, then we can find moles of elements in compounds. If we have moles, we can find as well molecules. You can say Avogadro's number of particles. Okay. How many moles and formula are in 41.6 gram of ammonium carbonate? Okay. We have the formula of we have mass given. So by using its molar mass, we will find moles and then convert into formula, number of formula by multiplying by this. This is the whole procedure. You can use this and calculate the values for this question. Okay. Mass question and the chemical formula. Okay, the formula shows the number of moles of each element used in the calculate mass percentage of each element on mole basis. Percentage of element X. Okay, moles of X, molar mass of X, mass of 1 mole of compound multiplied by 100. So by using this formula, we can calculate mass percentage of an element. Okay, we have to find mass of 1 mole of compound, molar mass of the element, and the moles of X in that. Like you can say, okay, we have given. Okay, problem here, 6H12O6. What is the mass percentage of the element in the glucose? Find by yourself. Okay, how many grams of carbon are in 16.55 grams of glucose? Okay, let us see. Plan. The formula gives the number of moles CH and O in glucose, convert from moles to elements to grams using the molar mass. Okay, let's see mass. Okay, mass, how is it? Moles of carbon is 6. You can see here 6 carbon atoms. Okay, 6 carbon, mass is 12 gram. We will get 72.6 gram of carbon. Okay, dividing by the mass of 1 mole of glucose gives the element's mass fraction. Multiply this fraction by 100 gives the mass percentage. This is mass fraction. Total mass of carbon is 72, mass of 1 mole of glucose 180. We will get 0.4 grams of carbon per gram glucose. Okay, mass percentage, mass fraction of C. Okay, what we get? 0.4 and multiplied by 100. 0.4 multiplied by 100, that means 40% mass percentage of carbon in glucose. Okay, for same for hydrogen as well, like moles of hydrogen. Okay, that is 12 in glucose, and mass of hydrogen 1.008, and mass of 1 mole of glucose is 18 gram. Okay, we multiply it by 100 and get 6.714 percentage of hydrogen. Okay, we can use this for oxygen to be more like we can also use other method, like we can see here, like adding both hydrogen and carbon and subtracting it from 100. carbon percentage and hydrogen percent. We divide this like subtract this, and we will get percentage of oxygen. You can use also this formula as well. Okay, determining the mass of carbon. Okay, mass of carbon, mass of glucose into fraction of carbon. Mass of glucose is 16.5. This is second part. Okay, 16.5 gram in second question. Okay, percentage mass fraction of carbon, we find it earlier, 0.4, and we will get this amount of carbon. Okay, concept 5, the procedure for finding the empirical and molecular formula. If an unknown pure compound can be decomposed, the masses of elements present can be determined. Converting the masses to moles of elements leads to the empirical formula. Okay? We have mass, we use molar mass, and then we convert those masses into moles to get the you can say empirical formula. The simplest whole number ratio of moles for each element in the compound is called empirical formula. Okay, as for here an example, a compound contains 0.21 mole zinc, 0.1 mole for phosphorus, 0.56 mole of oxygen. Okay, preliminary based on the data. Okay, we write this, convert the fraction subscript to the whole number. Okay, what we have to do, first divide all these things. You can divide by the smallest number. All of 3 is 0.14. We divide every quantity with 0.14. We will get this. Okay, 1.5 of zinc, 1 of phosphorus, 4 of oxygen. You can see it is in fraction, so we can we multiply it by, like, you can say some number to get the whole number ratio. Okay, so we multiply I think by 2, then we will get Z3, P2 and O8, and you can say this is the empirical formula, or we can write this Z and 3PO4 twice. The compound is zinc phosphate or dental cement. Okay, this is how you can calculate empirical formulas. Okay, analysis of a sample of an ionic compound give this grams of sodium, this gram of chlorine, and this gram of oxygen. What is the empirical formula and the name of? Find empirical formula first and then name the compound. What is the first step? Convert the mass of an element into moles, and use number of moles as subscripts, or use like you can use another way, like write moles and divide by, like you can say the smallest number of moles. Preliminary formula change to integer subscript. Empirical formula we will get. We are finding moles here. You can see we find moles of sodium, chlorine, and oxygen. Okay. Then what we will do, we will divide it by the smallest number of moles, like 0.123 of the each term. Okay, we will get 1, 1, and 4. 1, 1, and 3.98. You can say we will round it off because it is like close to 4, so we will write the formula as NaClO4. What is the name of the compound? We have, like you can say, we have two numbers. We have two questions there, finding the empirical formula and name of the compound. The name of this is sodium perchlorate, and this is also the molecular formula of sodium perchlorate. This is the simplest whole number ratio as well. Okay, molecular formula. What is molecular formula? How we can find this? Actual number of moles. We studied earlier empirical formula. The simplest whole number ratio. It is like actual number. It is not the simplest whole number ratio. In water, H2O. This is also the empirical formula. This is simplest number ratio as well. Okay, NH3, methane, and anicamol. The empirical formula and molecular formula are identical for these substances. Okay. In some cases, the molecular formula is a whole number multiple of the empirical formula. Using the empirical formula to obtain molecular formula. Empirical formula of HO is this. Its molecular mass is this, or you can say empirical formula mass. Dividing its molar mass by 34 by the empirical formula, its molar mass is 1. Okay, we will get this. Like you can say molar mass is 34. Okay, and it is because hydrogen peroxide has empirical formula is H2O2. Okay, as its molar, you can say molecular mass or molar mass is H2O2, 34 gram per mole, and we have empirical formula mass 17. We divide it by, we get the number that is 2, n. We represent it by n, and we multiplied this n value, like you can say the formula whole number ratio. We get this 2, n is equal to molecular mass, molecular formula, and empirical formula. Okay, we multiplied empirical formula by 2, then we will get the molecular formula H2O2. Another question there, lactic acid given molar mass is given, contains mass, percentage of carbon, hydrogen, oxygen. Using the above procedure, try to solve these questions. I am sharing the answers with you. Okay, you can see here answers. Okay, 3.3. Okay, you can pause the video and check it out. Alright, combinational analysis is used, like you can say, to find the empirical formula of the compounds. Okay, this is another question there. You can say, like, this is not included. Yeah, how we can find mass of CO2? You can say how can find the fractions of, it is for organic amount, C value of mass fraction of C, H, and O. Okay, we will write moles, multiply molar mass divided by mass of 1 mole. Okay, of the compound CO2. Okay, for hydrogen we will use H2O. Okay, we'll find this, and then okay, mass of carbon 1.5, or you can like this way. Okay, calculate the like O by difference. I told you earlier as well. Okay, here's a question. Find the moles. We have like mass by each smaller mass given this. We will divide it by the smallest number, that is 0.0341. We will get these values. We multiply it by 3, then we will get C3, H4, and O3. Okay, like this is like simple overview. Okay, determine the molecular formula. Okay, by using the like process like we discussed earlier, how to find the molecular formula. Chemical formula and structure of molecules. Chemical formula represents the three-dimensional object. Molecular formula tells the number of each atoms of atoms. A molecular formula may not be unique. The same types and number of atoms can bond to each other in more than the other way. Okay, can different compounds or structural isomers of the same compound, same molecular formulas. Structure formula. These you can see here. This is concept 6. The importance of balancing equations. Okay, the same number of each type of atoms must appear on both sides of the equation. Okay. For an equation to be accurate, the amount of chemicals involved in the reaction must be balanced. Okay. Here, reactants into yield products, Mg plus O2 yielded, and it forms MgO. We balance the chemical 2 here, 2, and there is 1. We will get 2 MgO. Okay. Each blank must stepwise match the atoms on each side. Okay. 1 here. Okay. Requires 1 Mg on the left. This is, you can say as well, this is the like, if you like get 2 moles magnesium and 1 mole, we will get 2 moles of magnesium oxide. Okay, we can use like this way, 1 mole of magnesium and half mole of oxygen gas, we will get 1 mole of magnesium oxide. Okay, you can see here we multiplied by 2 whole number. So this is the formula, balanced chemical equation, you can say, for magnesium oxide formation. Specifying the states of matter. Okay, you can see solid, liquid, and solid. Like this is the like, you can say, a limitation of chemical. This is the like, you can say, balanced chemical equation. Balanced chemical equation cannot tell us about, like, you can say, about the physical states. Okay, when we were studying stoichiometry, it is like, you can say, thermochemical equation. Okay. Okay, here's a question here. Balance the equation by yourself. Okay, pause the video and do it. Okay. Okay, this is the process how we can do this. Okay, step by step, and we will get our answer here. Okay, concept 7, the mole mass number information contained in a balanced chemical equation. I think the video is too long, so we will discuss this in another video. Thanks for watching. I hope you enjoyed the lecture.